substitution method. In the examples here, it has specified that we want to start with the substitution method. I just want to make sure that you remember both of them. But unless it is specified in the test, you can choose whichever method you are most comfortable with or which one fits better for the question that you've been given. Okay? So substitution method is where you want to get one of the pronumerals by itself and sub it into the other one. So looking at those two equations that I've been given there, whenever there's numbers out the front there, they're obviously going to be harder to get that letter by itself. The easiest letter to get by itself is a nice little X or Y sitting by itself like this. Okay? So that's the equation I'm going to start with. And my computer keeps doing this today. I'm terribly sorry. It keeps flashing up things. And
Do you remember to record?
I am recording. Hello, people at home. Yeah, they can hear you guys too.
Oh.
Hey guys.
Hi. Okay, so anyway, we're starting with this equation, and we're going to get the y by itself, and that will mean I need to move the 4x across to the other side. So I'm going to subtract that 4x away so that the y is by itself. Now, we like to label our equations. The first one, the top one, is going to be equation 1. This equation that I've just rearranged is going to be equation 2. And we are doing substitution method, so what I'm going to do, the equation that has y by itself, so equation 2, I'm going to substitute that into equation 1. And what that means is I take what y is equal to in equation 2 and I replace that in the equation for equation 1. Okay, so I write down what equation 1 is, so 3x minus 2, but instead of the y, I replace that 24 minus 4x equals to 29. Okay, then I have to solve that for x, so we expand the brackets out. 3x minus 48 minus makes a plus, 8x equals 29. Then I've got some like terms to collect there. 3x plus 8x is 11x minus 48 equals 29. And then add the 48 to the other side. 29 plus 48, yep, I can hear the calculators, good, 77. And then divide by 11, and we get 7. Don't forget that once you have got one of your values, you still have to find the other one. I still have to find y. So I'm going to sub that back into equation 2. You could choose equation 1 if you want to, but equation 2 already has y by itself, so that will be the one that will give me the answer. It's just a little bit easier. So I'm going to say, therefore, y equals 24 minus, and it's 4x, so that is 4 times by 7. Okay, 4 times 7 is 28. 24 minus 28 is minus 4. Okay, we like to write our solution as a coordinate, so let's do that over the side since I'm running out of room. X was 7, y was minus 4. Done. All right. It's not going to be quite as easy as last year. We want a few little challenges. So looking at this next one, y is equal to x squared and y is equal to x plus 2. We did a little bit of this, especially those of you that did the quadratics with me. We have a quadratic equation in there. Okay? So we're still doing the substitution method. So this is going to be equation 1. This is going to be equation 2. Y is by itself for both of them. So if I'm going to sub 1 into 2, that means I'm going to take the x squared from here and I'm going to put it in there where that y squared is. Okay, so that means I'm going to get x squared equals x plus 2. I have a quadratic equation in there. Put all the x's on one side. X squared minus x minus 2. Move everything over to the left. And we have the trinomial. We have the 3 terms. So we're looking for 2 numbers that times to give minus 2 and add to give minus 1. Where's the negative sign? Negative 2 plus 1. So straight into the brackets. X minus 2, x minus 1. Using the null factor, we can get very easily... Oh, plus, thank you. We can very easily move the minus 2 across. So for the first one, x would be equal to a positive 2. Or for the second bracket, x would be equal to a negative 1. Okay? Don't forget about the y values. Equation 1 or equation 2, where do you want to sub them?
1.
Equation 1, all right. So that means that when x is equal to 2 in equation 1, I would get 2 squared, which means y is equal to 4. Okay, that gives me a point. X is 2, y is 4. Then for the second one, if x is equal to negative 1, again, subbing that into equation 1, it's x squared. Don't forget if you're squaring a negative, it's negative 1. I hope you don't need the calculator for that. But as a general rule, when you're squaring a negative, don't forget you're squaring that minus sign. Okay, so y is going to be equal to a positive 1, which gives the solution negative 1, positive 1. All right, good. Substitution method, done. Question 2 is the elimination method. So elimination is when you want to have, you're looking in the columns, so you've got like an x column and a y column, and you want the x's to either be the same or the y's to be the same so that you can add or subtract your equations and eliminate one of them, hence elimination method. We're trying to eliminate one of them. So again, not giving you much of an easy one here to start with. Nothing is the same at the moment. 3x, 4x, 2x, 2y, 5y, different, okay? So we're going to have to choose, do we want to make the x's the same or the y's the same? X's. All right, we're going with the x's, are we?
Yes.
All right. So that will mean if I have got 3x here, I'm going to have to times that whole equation by 4 because I have a 4x on the bottom. And that whole equation, I'm going to times through by 3. So then, let's times those through. 3 times 4 is 12x minus 2 times 4 is 8y and 4 lots of 29, 116. All right, second equation times everything through by 3. So 4 times 3 is 12x plus now 5 times 3 is 15y and 8 times 3 is 24. Okay, so we've had to adjust our equations from the start. But now our x's, we've made them the same. They are both 12x's. So the next job is, do we have to add those equations or subtract those equations to make them eliminate? Do I want 12x plus 12x or is it going to be 12x minus 12x to make it 0? Minus, okay? So treat it like a big giant sum, you know, back in primary school where you did the big summing thing. And I'm going to put a minus sign out the side here. I'm going to subtract those equations. 12x minus 12x, they will cancel off and I get nothing there. You don't really write the 0, okay? We don't need that there. So our y's, we have a minus 8 and then we want a minus 15. So that's minus 23y. Then, last one, the numbers, 116 minus the 24, 92. All right? X's are gone. One little step to get that y by itself. I divide by that negative 23. Y equals negative 4. Once you have got one of your pronumerals, we have to sub back in. So there is still a substitution in here. We have to sub back into one of our equations to find the x. What equation? I didn't actually label any of them. Top one or bottom one?
Yes.
Top, all right. So 3x minus 2y, but y is minus 4, so minus 2 times minus 4 equals 29. Minus 2 times minus 4 makes a plus 8 Solving the two-step equation, subtracting the 8, 3x equals 21, and dividing by 3. Finally, write your solution as a point. X is 7, y is minus 4. All right, and looking at B, you can see it already. Look at all those lovely squares in there. Quick quiz time. X squared plus y squared, what kind of graph? Yeah, good job. It's a circle. That was just a side note. Okay, so to solve this equation, we don't normally, to be honest, doing elimination method with squares in there doesn't happen very often because it's very rare that you can actually get the things the same. This is just a really special one here. I actually have got, my x's have got the same coefficient. They are actually kind of like, you know, I can actually subtract them, I can eliminate them, okay? Or the y's if I wanted to add them, okay? So very rare, but it does happen. If I do equation, I'm not doing substitution, it's all good. I'm doing elimination. There we go. Equation 1 and equation 2, I am going to subtract them. I didn't do my instructions very well last time, so I'm fixing that up. 1 minus 2. So, x squared minus x squared. 0, gone, wonderful. Y squared minus y squared. 2y squared, beautiful. 53 minus 45, 8, lovely. Okay, then just getting that y by itself. So divide the 2 and square root. All right, is that correct? No. Trick question when I ask something like that. What have I missed? Yes. Oh, yeah, that. But I mean that y value first. Plus, minus. Yes. I have square rooted a number. It could have been a plus or a minus 2. That squared would have given me 4. This is where, when you have a quadratic, you expect to get 2 solutions. Okay, most of the time. All right, and this is where it comes. So I have got a y equals a positive 2 and a y is equal to a negative 2. I'm going to split them so that I can do my x values underneath, okay? So let's substitute into the first equation. X squared plus y is 2, so 2 squared equals 53. 2 squared is 4, so I'm going to subtract that in one move. 53 minus 4 is 49. And when I square root that, what do I get? Plus or minus 7. Do you know what that means? I've actually got x is a plus 7 and y equals 2. X equals a minus 7 and y equals 2. I get 2 points just from that one. Let's do the other one. Or, let's do minus 2. Subbing into that first equation again, we get x squared plus, it's minus 2 squared equals 53. Again, minus 2 squared is going to make a plus 4 again, so we're going to get x squared equals 49, and we get x is equal to plus or minus 7 again. But that means x equals a plus 7, y equals a minus 2, x equals a minus 7, y equals a minus 2. So there's 4 points of intersection. What a fabulous question.